5-6, we are talking inequalities in triangles. So first thing we're going to talk about is called the comparison property of inequality. And the comparison property says this: if you have A equal to B plus C, okay, so you have an A over here, you have a B plus C over here, they are equal to each other. And the C, so this number, is positive, greater than 0, okay? Then it has to be true that A will be greater than B. Does that make sense? If you have to add something to B to get A, then A has to be the bigger of the two numbers, right? So that's the comparison property of inequality. And then there's a little corollary to the triangle exterior angle theorem that comes into play with that. If you remember the exterior angle theorem, what did that say?
It said that some two had like
Not equal more, equal the exterior angle, right? So your two remote interiors had to equal the exterior. That was this right here. If we're looking at this picture, the measure of angle 3 has to equal the measure of angle 1 plus the measure of angle 2, right? Add the two together and it will equal the exterior associated with those two angles. The corollary says that means, therefore, that this angle by itself has to be greater than either one of these by themselves, right? Because if you have to put 1 and 2 together to make it equal 3, then 1 and 2 are both less than 3 by itself, okay? So it's just comparing what's greater, what's less, based on how we're setting up an inequality or an equation. So the measure of angle 3 will be greater than the measure of angle 1, and the measure of angle 3 will be greater than the measure of angle 2 because 1 plus 2 will equal 3, okay? So with that idea, they're going to give you a picture, and we don't do a ton with this idea, but I want you to understand what is going on with this picture. They're going to give you a picture that looks like this and ask you, why is the measure of angle 2, why is that angle greater in measure than that angle? And you can't just say, well, it looks like it is. There's reason, based on the markings that you see in this picture, that angle 2 is greater than the measure of angle 3. So tell me something you know about this picture. Anything.
It's an acute angle.
What's an acute angle?
Triangle YT. Nah, the angle.
YTP is all acute,
No.
okay?
So that means angle 1 is equal to angle 2.
Because it's isosceles, right? Because they marked these congruent, then these two base angles are congruent. So we can say the measure of angle 1 is equal to the measure of angle 2. Okay, so we know that is true. What else do you know in this picture? I'm going to highlight a triangle for you and see if it helps you see what I'm looking for. Right. So angle 1 is an exterior angle with the remote interiors of 3 and 4. So we know the measure of angle 1 equals the measure of angle 3 plus the measure of angle 4. Okay. So if we know these two things, can you write a new equation using substitution for me? What?
Angle 2 equals angle 3 plus angle 4.
Right. So that's just substitution, right? We just substituted. So I know that 2 is equal to 3 plus 4. So then this theorem that we just learned, right, this guy up here, the corollary to the triangle exterior angle theorem, says that if this is true, 2 equals 3 plus 4, then what is true?
Angle 2 is greater than angle 3.
Right. The measure of angle 2 has to be greater than the measure of angle 3 by the triangle exterior angle theorem. Technically, it's the corollary. but I'm not super concerned about you naming it the corollary. Is that right? There's only one R. I spelled it wrong. Corollary. So you're just looking at relationships. How does this affect this, and how does this affect that, and where do you end up? That's where you end up. That's how we know that 2 is greater than 3. Okay? Questions on that? Okay, these next couple theorems are more what you're going to be spending the most of your time on. So let's look at Theorem 510 here. Theorem 510 says if two sides of a triangle are not congruent, then the larger side or larger angle lies opposite the longer side. Okay, and I'm going to draw you a picture here just to help you visualize that. So let's say this is X, this is Y, and this is Z. Okay. It says the larger angle is across from the longer side. So if you look at this picture, if I say that XZ is greater than XY, okay, so the length of XZ is longer than the length of XY. What this theorem is saying is the angles across from those sides are linked to those sides. So the longer the side, the larger the angle across from it. The shorter the side, the smaller the angle across from it. So if XZ is greater than XY, then what is also true is that angle Y is greater than angle Z. Okay? And the way you can kind of remember it, if you think of my arms as making a triangle, okay, so pretend there's this third side of the triangle over here. If I make this bottom angle bigger, what just happened to my third side? It got longer, right? If I make that angle smaller, my third side got shorter, okay? So if you forget, just keep that in mind. The angle and the side across from it are the things that are related to each other, okay? So if you look at example 2 here, it says list the angles from smallest to largest. And here's the thing, guys. You are bright people. I know you're bright people. I need you to prove to me on the test that you're bright people, because inevitably someone will always on this problem list the sides in order from smallest to largest. I gave you side lengths. I gave you 4, 6, and 7. Don't tell me that CB is the shortest side. I know that. I told you that. I told you it was 4, right? I want you to list the angles. On another problem, I'm going to give you the angles, and you're going to list the sides. So please read the directions. Tell me the right thing. If I'm asking for angles, give me angles, not segments. If I'm asking for segments, give me segments and not angles, okay? No, it's not inevitable. We're going to say this year's going to be different, and nobody's going to do it this year. I've never had a year like that. There's always been someone. But make this the year that you are not doing that. Okay, so if you look at this picture, we're listing the angles. What is the smallest angle going to be? A. Okay, note your shortest side is across from your smallest angle. So angle A is the smallest. What would come next? Angle C. Your next shortest side is the 6. Across from that is angle C, which means your longest side is across from your largest angle, and that would be B. Okay? Questions on that?
No question.
Okay, so then Theorem 511, very similar, slightly different, just in terms of what you're given and what you're looking for. So this one says, if two angles of a triangle are not congruent, then the longer side lies opposite the larger angle. Okay, so this is just looking at it the other way. Now we're going to list the sides in order from the angles that we have. If you look at example 3 here, what do you need to do first?
So what you want to do is find and measure that angle.
You got to find that third angle. So we have 58 and 62. What would angle T be? 60. It has to add up to 180, okay? So if you call this x, you're going to say x plus 58 plus 62, oops, equals 180 to find that missing measure. So this is 60. Okay. I want the sides from shortest to longest. What is your shortest side going to be?
TV.
That would be TV. So you have the smallest angle and across the way, the shortest side. Okay, so TV would be the shortest. What would come next? What would it be? UV, right? Your next smallest angle is across from your next shortest side, so UV, which means your biggest angle, oops, that's a pen. The 62 is across from the biggest side, which is UT or TU. Okay, so that would be the 3 from shortest to longest. Questions on that? Okay. Then there's the triangle inequality theorem. This one says the sum of the lengths of any two sides of a triangle is always greater than the length of the third side by itself. Okay, so if you are given a triangle, you should be able to add any two sides together, and the sum will be more than the third side alone. Okay, let me just show you why. So this is what it would look like. xy plus xz, or yz has to be greater than xd, so on and so forth. But this is why it works that way. Let's say I have a side length of 5 here. If I were to put a 2 here and a 2 here, and then hinge those, will you ever get a triangle out of that?
You will not get a triangle.
No, if I lay that 2 down, this is 2, lay this 2 down, that's 2, you still have 1 unit in between, they're never gonna meet, okay? So what if I have a 5, and there's a 3, and a 2? Will they ever meet?
Yes, because the
Where?
is gonna eventually, like the two's gonna be like this, and it's gonna go,
When it finally gets it.
and it's gonna.
When it lays flat though, right?
Yes.
Are you getting a triangle out of that?
No, you're gonna get a
No.
straight.
You're getting a line.
Because they're equal. 3 plus 2 is not greater than 5, it's equal to 5, okay? The rule is the 2 have to be greater than the 1 by itself. So if I did a 3 and a 3, that would work with a 5, because 3 plus 3 is greater than 5, okay? So look at example 4 there. It says, do these lengths make a triangle? You should be able to set it up that 3 plus 7 is greater than 8, that 3 plus 8 is greater than 7, and that 7 plus 8 is greater than 3. If all 3 inequalities are true, it will make a triangle. If any one of them is not true, it won't make a triangle, okay? Does this make a triangle?
A does, B does not.
Yeah, so this is 10 is greater than 8, this is 11 is greater than 7, and this is 15 is greater than 3. Those are all true. So would it make a triangle? Your answer would be yes, okay? You want to know a secret?
Yes.
You don't have to do all 3. Which one do you think you have to check?
The largest one, smallest one, the one in
The two small ones.
If you take the 2 smallest numbers and add them together, and they're bigger than the biggest number, if that one works, they will all work, okay? So technically, all you really had to check was that one. Does that make sense? Now, you're welcome to do all of them. I'm not trying to rob you of the joy of doing more math, but just so you know, you could just check the one. Okay, so for this one, 3, 6, and 10, are you going to get a triangle?
No,
Why not?
because the 3 and 6 are not greater than 10.
3 plus 6 is not greater than 10. So this would be no. What about if you did 4, 6, and 10? Would you get a triangle? Why not? Has to be greater than, not equal to, right? 4 plus 6 is not greater than 10. So if it equals the same, gentlemen, doesn't matter, okay? It has to be greater than. So this would still be a no. Okay, this looks like your last one, but I'm actually gonna add something after this. So this one is a little bit different. Now they're gonna give you two of the sides, and they're gonna say, what are the possibilities for the third side? This is not a like, 16 is your answer. It's not like that. You get a range, because you could have something as low as this, or you could have something as high as that. Your job is to figure out what is that range. What are the options for your third side, okay? So if this one says you have side lengths of 8 and 10, what are the possibilities for the third side? What do you want to call the third side?
X.
Call it X, okay? Taylor, you with me back there? I haven't seen eyeballs for a long time. So if our three sides are X, 8, and 10, you should be able to set it up with 3 inequalities. What are those 3 inequalities going to look like?
Okay, I got you. I know the first one. So you want to do x plus 8 is greater than 10.
10.
And then
Okay,
you wanna do
so that's one of your inequalities, right? The 2 added together greater than the third. What's another inequality that you have to set up?
x plus 10.
8 plus 10 is greater than x. And what's the third one?
10 plus
X plus 10 is greater than 8. Okay, so those are the 3 ways you could set up the inequalities. Now you solve them. If I take away an 8 here, I get x is greater than 2. If I simplify here, I get 18 is greater than x. And if I simplify here, take away 10 on both sides, I get x is greater than negative 2. Okay, now let's think about this. We're looking for a range of possibilities for a third side. One of these doesn't work. Which one?
With the negative. Oh, yes,
Maybe the one with the negative. Why wouldn't the one with the negative work?
because it's not a
Because
possibility.
it'll be like this.
So
It'll be
why
like the
does it
segment,
range?
and then it'll be like one going that way, and then it'll be like one going that way. So that's
No, you're wrong. I'm sorry.
No, can you have a negative side length? No.
And then it won't be
So that is part of the issue. Does anyone see another reason why the negative one doesn't matter? Reagan. Right. If it says it has to be greater than 2, it's going to be greater than negative 2, right? So this one is trash. Every time you see a negative, that's the one you're going to get rid of. There will always be a positive and a negative with the same number. Get rid of the negative one, okay? This means that our range of numbers is greater than 2 and less than 18. So you can write it like this, between 2 and 18, or you may write it like this. Okay, that will be your answer. It will be a number between 2 and 18. So can one of your sides be a length of 2? No, between. That does not include that number, right? Has to be greater than 2, not equal to 2. Okay, now here's another question for you. Does anyone see the shortcut? Just trying to give you ways to not have to do so much work, guys.
Well, I haven't.
Camille. Right. Okay, so here's the deal. I gave you 2 numbers, 8 and 10. If you add them together, you get your high end. If you subtract them, you get your low end. Isn't that fantastic? So what if I told you that your numbers were, you all right?
I'll put my iPad away.
7 and 19, and I want to know the possibilities for the third. Subtract them, you get 12. Add them, you get 26. So your answer is between 12 and 26. I gave them to you. Okay? Questions on that? Okay, I have one last problem for you, and this one is notoriously done wrong, so pay attention. Draw a picture with 2 triangles that look nearly equilateral. Nearly.
I see what you did at the corners of the triangles.
No, we're pretending those match up. All right. So if this is 59 This is 61. This is 60. And this is 57. I'll give you a second. Okay, so here it is. The question is this: which segment in this whole picture is the longest? Okay, which segment in this picture is the longest? What's the first thing you need to do?
You need to find those two measures.
You need to find the two missing measures first. Okay, so if we're looking at the triangle on the left, triangle ABD, you have 59, you have 61. What would that angle be?
Oh, snap.
60, right? It has to add up to 180. Do you mind? Okay. Then look at triangle BCD. You have 60, 57, and C have to add up to 180. What would that be?
Oh, I forgot to do
32.
63. Okay, so you have all of that. The question is, which segment is the longest? Think about it.
Oh, BD.
Nope.
AB.
But everyone wants to tell me BD all the time. Why? Because what? Mm-hmm.
Oh, you gotta combine.
So-
angles, right?
Let's treat them as separate triangles real quick. In this triangle, what segment is the longest? BD,
I.
right? Across from the 63, that is the longest side on that triangle. Now look at this triangle. What's the longest side in that triangle? AD. Okay, now here's the thing. People are always like, but how do you determine which triangle you're working with? If you look at your two longests, they will both be part of one triangle. Which triangle are they both part of?
ADB.
ADB. So, if that's the case,
They're part of the triangle, right?
in this triangle, this is across from BD. This is across from AD. Which of those two is longer? AD is longer. Remember how there isn't an AAA postulate, right? I can have 59, 61, and 60 look like that. Or I can have 59, 60, and 61 look like that. So you cannot just say, well, the 61 is the biggest, right? So it's across from the biggest side when there's another triangle attached to it that also has its own individual longest and shortest sides. So you have to pay attention to the whole big picture. On this triangle, set of triangles, AD would be the longest because between the two longest of those two, AD is longer than BD. Okay? So don't just go with the biggest number on the page. It doesn't work that way.
But I was right.
No, you told me BD.
Oh, it's AD.
It's AD. Yeah. Okay? Questions on that?